Okay.
In the last video, we talked about checking the remaining holding space. Because we must pay attention to this E, the remaining
Anytime,
holding space
anywhere.
of MMC, we also talked about the second one. What about the remaining memory? Because if you use 1 now, there will be 1 less. 1, that's when our multiple services are centralized. Let's talk about it in this issue, how to use the remaining disk space to exchange virtual memory. Now this virtual memory is 415 trillion. Then 43 was used, idle 372. If later we need some high memory services, we may have to add 500 or 1 gigabyte of memory, but the corresponding disk will also decrease corresponding to the corresponding disk capacity. Here we're going to shout the order to copy it. For example, I'm going to put it 415 trillion enough now. I'm going to expand it 100 trillion. Then we paste. The core parameter is this, 100 trillion. Remember, this is virtual memory, 415. Let's go back and try. We'll take a look again when we get back. Okay, now it's 515. And it works after restart. What if later we run multiple images? Let's say we run 2 or 3 FRP nodes, node reader, and some MQTT, or if it is a message notification service. This 100 memory is almost not enough to make sure it doesn't get stuck or not get killed by the process. So we need to use its disk space to swap this virtual memory, although the efficiency is not fast enough to solve this memory shortage problem to a certain extent. Let's take a look. Just traded the disk for our virtual memory. The previous one was 3.2. Now it becomes 3.1, which means 100 trillion disk capacity set to virtual memory. So the corresponding less 100 trillion. Today is probably to explain such a the concept of virtual memory. Use the command line to operate, then to solve. We will run multiple services in parallel or high concurrency, low memory problem.